Now let's start off with the nomenclature of the carbon-containing compound. Now you have so many carbon compounds, as we have already said, that you cannot remember the name of each and every one of them. So what we are going to do is, there is a method which is prescribed by the IUPAC, which is nothing but the International Union of Pure and Applied Chemistry. Now they have set a method for us in order to name any compound. So let's take an example of the compound which is flashing now on the screen and understand the rule. So the first rule is that you need to count the number of carbon atoms in the compound. So over here you have 1, 2, 3 and 4. When you have 4 carbon atoms, it is nothing but butane. So you write down butane first. And then you notice that you also have a functional group. So as per the rule, in case you have a functional group, what you do is you have to indicate it using a prefix or a suffix. So over here you have the carboxylic group, which is nothing but COOH. Then you have C double bond O and OH. So now as you have a carboxylic group, the suffix for this is OIC acid. So what you're going to do is, you have to integrate this oic acid into butane. So first off, you're going to remove the E and you're going to replace it with OIC and write an acid in front of it. So what compound you have in front of you is nothing but butanoic acid. Now let's take another example and see if we have understood. Now in this case, what we are going to do is we're going to consider an alkene. So let's follow the rules again. You have 1, 2 and 3 carbon atoms and you have a double bond, so it's an alkene. So when you have 3 carbon atoms, it is propane. So first you write down propane, and now as this is an alkene, not an alkane, you are going to replace the A and E by E and E, and hence the compound that you have is nothing but propene. Now what if you have a triple bond in place of a double bond for the same compound? So you're going to replace the A and E by Y and E. So this becomes an alkyne, which is nothing but propyne. Now what if you have a halogen group attached? So what you're going to do is, again we're going to count the number of carbon atoms. So you have 1, 2, 3 and 4 carbon atoms. But remember, even when you count the carbon atom, remember to start counting from the side which is closest to the branch or closest to the substituent that you have, which over here is the chlorine, or where you have the double bond. So over here you have the chlorine group, so we're going to start counting first. We have 1, 2, 3 and 4 carbon atoms, and hence again it is butane. Now on the first carbon atom you have a chlorine atom. So as you have a chlorine atom, what is the abbreviation or what is the prefix for chlorine is chloro. So you add chloro to butane and hence you have a chlorobutane as the compound. Now what if you have a branch of methyl? Let's consider this example wherein you have a CH3 group attached to one of the carbon atoms. Now you're going to start counting from the side which is closest to the branch. So you have 1, 2, 3 and 4 carbon atoms. Now one thing that we need to remember, when you have this kind of a compound, what can you do and which chain are you going to consider as the longest chain? This could also be a long chain, this could be a chain, this could also be a chain. So how do you consider it? What you're going to do is you're going to count the number of carbon atoms and see which chain forms the longest chain away. So if you consider this first, let's see, it's got 1, 2, 3 and 4 carbon atoms. So here you have 4 carbon atoms. Then let's consider this 1, 2 and 3 carbon atoms. This is shorter than this. and then you have 1, 2, 3, and 4 carbon atoms. So we're going to consider this as a chain, as this is the longest straight chain. So again, let's count the number of carbon atoms. We have 1 first, second, third, and fourth. So as you have 4 carbon atoms, you have a butane. But if you look carefully, there is a CH3 group attached to the second carbon atom. Now what are you going to do? How are you going to represent this? As this is the second carbon atom, you're going to denote it by 2 first, and the group that you have is a methyl group, CH3, which is a methyl group. Over here, remember one thing, CH4 is methane, CH3 is methyl. So you have a methyl group. Hence, what you have is 2-methyl butane as your compound.